When we graph exponential functions, we go right to our handy dandy calculators and type in the equation. Okay, so we're going to look at two graphs on the same axes. So I would suggest that you use different colors just to kind of keep your life a little bit easier, if you will. Our window is going to change a little bit so we can see the graph in or on the calculator screen. So let's walk right in. Let's turn our calculators on and get started with that. So my first equation is 1.5 raised to the x. And I'm just going to graph one at a time. Your calculator could graph them both, but for right now I'm just going to graph one at a time. Let's change our window given the window information they gave us in our notes. Do you remember how to change your window? Yeah.
Window button.
Yes, it's its own button, window, and we're just going to copy exactly what they have in the table there. And then if you push your graph button, you should see what our graph is going to look like. Okay? But we're going to go to the table so we can get some sort of points that might make our life a little easier. Yes?
What would you call that?
This is a curve. It's an exponential function. Okay? That's its official name. It looks to me like it might be hitting right here on the y-axis. Anybody want to guess what that point is? 0, 1. Yes, it is. Let's take a look quick at our table of values. Mine's in the wrong place, so I'm going to change that real quick. I'm going to start at like -3. And then look at my table. And sure enough, there's that 0, 1.
How come our graphs are
Yep. So we're supposed to, in our notes, just sketch the graph. So we don't have the markings, so we don't have to be specific about what points we're graphing. I just wanted to give you an idea of what those numbers were going to look like. So if we pretend that this point is 0, 1, our graph's going to go kind of like that. And let's label that since we're going to have two on the same graph. And then we'll go right back to our calculator and change our function to be 3 to the x. Anybody want to predict what that might look like? How that's going to be different? Okay, more of a straight line? Is it going to go in the same direction? Or do you think it's going to be...
It's going to go
think it's goes steeper? So again, if we push graph, it does look like it's going steeper. If we look at our table, so we can compare some of those numbers from before, that 0, 1 piece is still there, but those y values, 3, 9, 27, are increasing pretty rapidly. So you're correct. It's still going to hit at that 0, 1, but it is getting steeper, faster. Yes.
So is that how you'll know what it is?
You'll know that it's an exponential function because one side of it will trail off here towards the x-axis, heading towards 0.
Will it always go like this?
Or, yep, or I'll just draw it on here quick. It is possible, remember we saw yesterday that it could go that direction as well. Yep.
What happens to the end that's going straight or downward?
Sorry?
Eventually, will it just keep going down or will it continue to go
No, it keeps going down, heading towards 0, but it never gets to 0.
Really?
Yeah. Just a minute, we can talk about that in a minute. So both of these functions are increasing as x increases. Which is increasing faster? Yes. Our y equals 3 to the x. It's increasing faster. Now just real quick, 3 is called the base. and the x is the exponent. We talked about that yesterday, but just to be sure we've got that vocabulary.
When you just look on that website to see how our notes are, and we found our numbers really cool.
Good. Good.
I didn't look at it.
Let's go right into number 2. We're going to look at 2 different exponential functions. Before we start typing, someone talked to me about this second function. What is 0.25 really as a fraction? 1/4. So I could do 1/4 to the x. I'll keep it with the way they have it, but. So,
Are we doing 2 of them or just one?
let's just do one at a time again, please.
This one goes to the right.
So we don't need to change our window, and when we look at the graph, oh, this is one of those other way ones. I'm going to look at the table real quick. Does it hit at that famous 0, 1 point?
Yeah.
All right, and we've got 8, 4, 2, 1 for our numbers. I think we looked at this one yesterday in our notes. And then this one might be a little difficult to see the difference between. This one's steeper. So if we go look at our table, oh, they were, I think it was 8, 4, 2, 1, and we're at 64, 16, 4, 1. So this one is getting steeper, faster. Still hitting that famous 1 spot though. Just because I want to show you. I'll throw both of them on the graph so you can see the difference here real quick. So that darker line, curve that it just graphed is the 1/2, and the 1/4 is the one that appears to be a little skinnier. Mm-hmm. Yeah. Okay, so we've got them sketched, we have them labeled. Letter B, why do these graphs decrease when the ones in exercise number 1 increase? Okay.
These ones are less than 1.
Okay. Fraction or decimal bases. The big number, if you will, is a fraction or a decimal. Or as Angelina said, the bases are less than 1. Which function decreases faster? And it was our red. So that smaller fraction actually decreases faster. 1/4 is smaller than 1/2. To the back. Complete each statement below. For B and C, use either increases or decreases to complete the statement. Letter A. Each exponential function of the form y equals b to the x. Whoa. Y equals b to the x. What do you think about this? Is that okay? You know what they're talking about? The b is the base, yeah? Yeah, b is the base. So what, just any of those examples that we had on the front is what they're referring to. What is the y-intercept of each of those functions from the front? Right, where across the y-axis is the point 0, 1. Good. For every single one of those. Letter B, if the base b of the exponential function is greater than 1, okay, then the function is going to increase. That was our first example. I can't spell. And if the function is between 0 and 1, so a fraction or decimal, it will decrease. What if we have a negative base? Great question. It's not in our notes. Let's take a quick look. I'm going to clear these. So what if we have -2 to the x power? Well, this graph might not work for it. Let's do a zoom 6. Can you get anything there? Huh. Well, let's go look at our table. What in the world is going on? Whoa. Whoa, whoa, whoa. What's going on? Why do we have positives and negatives bouncing all over the place?
I don't have any.
What's going on? How come that is fluctuating so much like that? What did we raise to the power? X is our power. What's our base? -2. So, let me just do a little math out here to the side. If I do -2 squared, that really means negative times a negative is a?
Oh, and then if it's to the third, it's multiply that 3 times, so it'll take it to the negative.
Right. And then we get back to a positive exponent, so now we're at positive
So that graph would
16.
be all weird and.
It's going to be all weird, and yep. I wonder why they didn't include that in our notes. You're right. Scary stuff.
Are we gonna do that?
No, we don't do that here. Let's move on to number 4. We have a couple of changes happening in our equation. They've given us a lead number there. Now, tell me, is this 5 being raised to the x power?
No.
Or just the 2? Just the 2, correct, whatever's in parentheses. These two equations are kind of like a savings account equation. That 5, or in the other example, the -3, are like our initial investment. Okay? Let's plunk those into our calculator. I don't believe our window, although they're telling us to change our window, I don't believe it changes a whole lot.
Wait, this one doesn't have to see one, does it?
Ooh. What?
Did I do something wrong or does
What
it
are you
not-
talking about? You didn't find a 0, 1?
Okay, I didn't do something wrong. I'm good.
Let me move mine up here just a little bit.
So 0, 5.
What happened there?
Okay.
What?
Why not they all hit?
Oh,
Yep.
those all did. What happened to this one? Where'd that
There's a
5?
number before the base.
Yeah.
Apply it to.
That number before the base shifts everything. Let's check out what this graph looks like. I know I have to change my window. Okay, so, look at that.
Are we supposed to sketch that?
We are supposed to sketch this. They also want us to label
The next one.
the y-intercept. So let me get my, so 1, 2, 3, 4, 5, and So let's read the directions here. We're supposed to sketch the graph, okay, did that. Oh, of both, well, we only did one. Label each with its equation, okay, and label the y-intercept.
Can it go negative, like upside down?
I don't know, let's see. Maybe this one will. We have a negative in there. How does that change everything?
I don't like it.
So -3, and it's still 2 for our base. So the only thing we're changing is that lead coefficient. Oh my gosh!
Well, why is that one big?
Look at that!
It's too big.
And then you have to go 0, -3. It's not 5 either.
What?
Oh my goodness.
We don't have the 0, 1 thing again either?
Found how you get the y-intercept.
You did?
Except it's the.
Yes.
Yeah, no.
Wow!
I think there for a
Look at
second.
that! Whoa!
So I don't even have to look on my phone.
You don't.
And it just.
Now, I just want to point out, this is very helpful because these bases are the same. Okay, so, bless you, we're sort of comparing two similar or same things. Not quite the same because of the 5 and the -3, but our base is the same for these. So these can be kind of fun. And you could certainly make some cool pictures with them and start graphing some different functions in here. Okay, so letter B says algebraically find the y-intercept by substituting x in for 0, or 0 in for x, excuse me. So,
5. It's just what we did on our homework.
5, 2 to the 0 power. Do you remember from when we did exponents, I think back in February it was exponents, anything to the 0 power is worth?
Nothing.
Try again. It's right by Morgan's head. She'll move her head. Very last semester. Anything to the 0 power is worth 1. Good answer. So, 5 times 1, 5. And sure enough, we already knew that was the y-intercept, but that's okay. Oh, my apologies. This is supposed to be labeled. Talking about that. All right, and then similarly over here, 2 to the 0 power is worth 2 to the 0 power is worth 1. Oh my goodness. Nice, okay. So what can we talk about here in number 5? Can you tell me if this graph is going to decrease, so decrease is in green, or increase?
It's going to decrease because of the decimal.
Okay, we're going to look at this and think about what we did on the front. If it's a fraction or a decimal, it's a decrease. Okay, good. So we'll get rid of our increase. Is it, what is its y-intercept?
25.
At 0.25. So we're going to pretend that this is 0.25, which, oh my, it's certainly not, but we'll pretend that it is. Make a rough sketch without using your calculator. Nice work today.